Find the equation of the tangent line for y equals the square root of x divided by the square root of x plus 2 at the point x equals 4. To find the equation of the tangent line, we need two things: the x and y coordinates of the point. Right now we have only the x coordinate. So first thing we need to do is find the y coordinate. We have y is the square root of x divided by the square root of x plus 2. So the corresponding y coordinate is found by plugging the x coordinate into that function. So the y coordinate will be y of 4, which will be the square root of 4 divided by the square root of 4 plus 2. Square root of 4 is a 2, so we have a 2 over 2 plus 2, which is a 2 divided by 4, reduced down to 1/2. And our point is therefore the x-coordinate of 4 and the y-coordinate of 1/2. The other thing that we need is the slope of the tangent line, and the slope of the tangent line is the derivative of the function y. Before we take the derivative, let's rewrite this with fractional exponents. The square root of x to the first power is x to the 1/2 power. In both the numerator and denominator, we'll have an x to the 1/2 over x to the 1/2 plus 2. Since we have a division, overall the derivative will require the quotient rule. So the derivative y prime, or dy dx, will be derivative of the numerator. We'll bring the power down, 1/2 x raised to the, subtract 1 from the power, so minus 2/2, times the derivative of the inside of the power function. That's just an x, so the derivative is just a 1 for the chain rule. Derivative of the numerator times the denominator left alone, x to the 1/2 plus 2, minus the numerator left alone, x to the 1/2, times the derivative of the denominator. The first term is the power rule, bring down the power, subtract 1 from it, multiply by the derivative of the inside of the power, the x, derivative, that's a 1 to complete the chain rule. The derivative of the 2 is a 0. All of this is divided by the denominator quantity squared. Now we'll simplify this a little bit. We have 1/2 x to the 1 minus 2 negative 1/2. Multiply with a 1, that doesn't change it at all. And then times x to the 1/2 plus 2 minus, and we have a 1/2. And here we're going to multiply these x's with each other. We add the exponents. 1/2 minus 1/2 will be x to the 0. X to the 0 is a 1, so that's really just going to be a 1. And then times that 1, which we don't need to write anymore, all over x to the 1/2 I can rewrite as the square root of x plus 2 quantity squared. So y prime, or dy dx, is going to be, I'm going to distribute this in now through here. I'm going to have 1/2 x to the negative 1/2 and x to the positive 1/2. We add those, that'll be x to the 0. Plus a 1/2 times a 2, which is a 1, x to the negative 1/2. And I have minus a 1/2 x to the 0 that's already there. Of course, x to the 0s are 1s, and we're going to write it that way, but all of this is over square root of x plus 2 quantity squared. So then x to the 0 is a 1. 1/2 times 1 is 1/2. This next term here, we have an x to the negative 1/2, and I'm going to move it to the denominator. It's only in the denominator of this term, so it'll be 1 over that, x to the 1/2, and then we have a minus 1/2 all over the square root of x plus 2 quantity squared. Now these 1/2s cancel. We have a positive and we have a negative. We only need to simplify this as much as needed to be able to evaluate it, we're going to be plugging in the point x equals 4. X to the 1/2 is the square root of x. I'm going to take this denominator and make it a fraction so I can reciprocate and multiply. Now I can multiply the numerators, that's a 1, and multiply the denominators, which I'm just going to leave the way they are. So here's our derivative, y prime or dy dx. If we plug in the point x value of 4, this will give us the slope of the tangent line. I have 1 over the square root of 4 times the square root of 4 plus 2 squared. Square root of 4 is a 2. So I have a 1 over 2 times 2 plus 2, which is a 4 squared. 4 squared is 16 times 2 will come out to a 32. So there's our slope of our tangent line. It's 1 over 32. We have our slope, we have our point, and now we can set up the equation of the tangent line using the point slope formula. It's y minus the y coordinate. Remember, our point's up here, so y minus 1/2 equals 1 over 32, the slope, times x minus the x coordinate of the point, also up here. That's the 4. This is the point slope formula. We're going to turn it into the slope intercept form by solving for y. To do that, we're going to distribute the 1 over 32n, and that'll give me a 1 over 32x minus a 4 over 32. Well, 4 over 32 can be reduced, and I'll do that before anything else. It reduces to a 1 over 8. We're going to be adding the 1/2 over. So I'm going to have a 1 over 32x minus a 1 over 8 plus a 1/2. We need a common denominator, so I can multiply this 1/2 by 4 over 4. So I have 1 over 32x minus 1 over 8 plus a 4 over 8. So I have the common denominator between them, and I can combine them together to get our final result. For our equation of the tangent line, 1 over 32x minus 1 plus 4 is plus 3 over 8.